My name is Dave Eastma. I'm the mission manager for Wallops aircraft at this time. My previous experience has been with the P3. I've done DC-8 flights, I've done Aerosonde UAV flights, and C-130 flights. I've probably got upwards to about 4,000 hours in the back of the plane.
Okay, my name is Bill Crable. I'm the project scientist for Operation Icebridge, and I've been flying missions like this in Greenland since 1991. The aircraft behind me is NASA's P3 research aircraft. It's used as a platform for various remote sensors, and we're going to be using it in Greenland this year, as we have most years since 1991, to collect a suite of measurements that tell the scientists the thickness of the ice and how fast it's flowing out to the ocean. And what we're observing is the decade of the 90s was exhibiting very small changes. If we saw a half a meter to a meter per year of thinning, that was a pretty large number in that time frame. But since the turn of the century, we're seeing some of those same glaciers now thinning at 15 and 20 and 25 meters per year. So there are some very drastic changes taking place up in Greenland. The additional work that we'll be doing for Operation Icebridge will be to follow the exact same orbit paths on the surface that ISAT has followed in the past and will follow in the future, and that ISAT-2 would follow when it gets launched in 2015. It does a very nice job of global coverage, particularly of Antarctica, that's quite remote and very difficult to get to with an airplane. So whereas the typical flights that we would make in the past are focused, targeted towards the outlet glaciers, we'll now also do the same kinds of measurements that a satellite would, and this sort of ties the two projects together.
I'm Jim Youngle. I'm a lead engineer on the NASA Airborne Topographic Mapper project. It measures the elevation of the terrain the aircraft flies over. It does this by firing pulses of laser light from the aircraft to the ground and back. Those pulses are scanned in an oval scan, and this allows us to map a swath of terrain underneath the aircraft, and it allows us to return in a future year and repeat those measurements pretty accurately.
We're concerned with the ice sheets of the world because to some degree they control sea level. Greenland is the second largest ice sheet in the world. It contains enough ice and snow that if it were to melt, it would raise sea level substantially, maybe as much as 20 feet in this area. You can imagine Greenland as a huge ice cube that's 1,000 miles long and 400 miles wide and 2 miles thick in the center. It nicely buffers global climate, regional climate, so that changes in the ice sheet become very important indicators of global climate change.
It's something you have to experience. We'll fly these patterns at 1,500 feet above the ground level, and you get up on the ice sheet, it's like flying over the clouds. When you look down, it's just white, fluffy sometimes. It just looks like a cloud, and you have to keep in your head that that's solid underneath you. Probably one of the neatest things to see is when you're flying down the glacier towards the ocean. You're at 1,500 feet, and just as you hit the ocean, the glacier drops off about another 1,000 feet. It's just, no matter how many times you do it, it always takes your breath.